Dear friends, I myself, Dr. Bharat Parab, discussing the topic problems on mathematical proof. This is covered in Appendix 1. Okay, so we are now trying to solve some problems. Okay, let us study some simple examples. As first one, find a counter example to disprove the following statements. Okay, there are some statements given. Okay, this is the first one. If the corresponding angles in two triangles are equal, then the triangles are congruent. Okay, okay, this is a statement and we have to disprove it. Okay, answer, consider the two triangles. See, A, B, C is one triangle and just giving it here first D, E, F, another triangle. Okay, so we will concentrate on this. This is that triangle, this triangle DEF. Okay, so in these two triangles ABC, that is the bigger one, and DEF, consider it here. This is just shown. Okay, now in these two triangles, angle A corresponds to angle D. Here, this is the same angle and are equal. Okay, angle B corresponds to angle E. Okay, they are equal. B is equal to E. Okay, this angle is equal to E. This angle C corresponds to angle F. Okay, this is green one and they are equal. Okay, so all the corresponding angles of the two triangles are equal, but the triangles are not equal. Area C is given here, but triangle ABC and triangle DEF are not equal in area, as base and height of both the triangles are different. Okay, so this is a counter example. That is how you have to tackle. Okay, second example, read, a quadrilateral with all sides equal is a square. The statement given, we have to use some counter example and disprove this statement or prove this that the statement is wrong. Okay, answer, consider these two quadrilaterals having all sides equal. Okay, this is a square where all sides are equal. Okay, and this is a figure where all sides are equal, but this is a rhombus. Okay, so statement which says that quadrilateral with all sides are equal is a square is wrong. Okay, a counter example to disprove the above statement. Okay, you can do this. Only one example is sufficient. Okay, third one, a quadrilateral with all angles equal is a square. Okay, this is very easy. Answer, consider these two quadrilaterals having all angles equal. Okay, this is a square. Okay, even this figure has all angles equal. Okay, but it's a rectangle. So this is a counter example where it disproves the statement. Okay, fourth one, for two integers a and b is integers, square root of a square plus b square. Okay, a square plus b square is under that square root sign. Okay, that is equal to a plus b. Answer, let a equal to 3 and b equal to 4. So under root 3 square plus 4 square is under this root 9 plus 16 is root 25 is equal to 5. Okay, and a plus b is 3 plus 4 is 7 5 is not equal to 7 is a counterexample to disprove this. Okay, you can have many, but only one is sufficient to disprove any statement. Okay, fifth one, 2n square plus 11 is a prime number for all whole numbers n. Okay, answer, take n equal to 11. Very smart answer. And this is 11. Then if you take this as 11, then cannot be prime number. Okay, you can remember this trick if you come across some such example in future. Okay, so take n equal to 11, then we have 2n square plus 11 is 2 into 11 square plus 11 is, see, 11 common, 2 into 11 plus 1, take 11 common. Okay, so 11 into 23. Okay, now this is product, so definitely not prime. Okay, got it, hence not a prime number. Hence n equal to 11 is a counter example, or it counters the statement. Okay, and sixth one, n square minus n plus 41 is a prime number for all positive integers n of n. Okay, same thing, take n equal to 41, as this is 41, here it was 11, we have taken n equal to 11, now n equal to 41, then we have n square minus n plus 41 is 41 square minus 41 plus 41, this cancels. Okay, you get the whole thing is equal to 41 square, and this is definitely not a prime, it's a product. Okay, hence not prime, hence n equal to 41 counters the statement. Okay, this important comment given here, need to give only one example. Okay, second one, theorem, prove that the sum of two odd numbers is even. Now we are dealing with two odd numbers and sum. Okay, to prove that, TPT, 2n plus 1 plus 2m plus 1 is even. Okay, proof, consider any odd numbers 2n plus 1 and 2m plus 1 for any positive values of n and m. See, whenever we have to take odd numbers, you always take in this form, that is 2n plus 1. This is definitely going to be odd number for any value of n, any positive value of n. Okay, and for m. Okay, so addition 2n plus 1 plus 2m plus 1, then we have the sum is this one, the addition in both these brackets, you get 2n plus 2m plus 1 plus 1, that is 2n plus 2m plus 2, taking 2 common, you get n plus m plus 1 into bracket. Okay, okay, so this bracket is multiplied by 2. See the argument here, very intelligent argument, as sum is multiple of 2, hence it is a even number. Okay, third one, theorem, prove that the product of two odd numbers is odd. Okay, now here we were dealing with odd numbers only, but sum, now it's a product. Okay, so to prove that 2n plus 1 into 2m plus 1 is odd, proof, consider two numbers 2n plus 1 and 2m plus 1. We have discussed this part here. Okay, so we are directly going, the product of these two numbers will be p equal to 2n plus 1 into 2m plus 1, that is equal to 2n multiplies to this bracket, that is 2n into 2m plus 1, and this 1 multiplies to this bracket 2m plus 1, so open the bracket, 4 mn plus 2n, okay, this plus 2m plus 1. So can take 2 common from this bracket up to here. 2 into 2nm plus n plus m, and plus 1 is added to the whole 2 and this product. Okay, so this plus 1 shows that product P is always odd. Okay, very nice and easy answer. Okay, so we move ahead. Now the fourth one, theorem: prove that the sum of three consecutive even numbers is divisible by 6. Okay, read this very carefully. We are trying to see the sum of three consecutive even numbers, okay, and show that it's divisible by 6. So to prove that, 2n plus 2n plus 2 plus 2n plus 4 is divisible by 6. Okay, now when you have to take even numbers, you always take in this form. 2n, this is definitely going to be even number, and next even number will be 2n plus 2, and next to that will be 2n plus 4. Okay, so see, we are giving this in proof. Consider any three consecutive even numbers, and that will be in the form 2n and 2n plus 2 and 2n plus 4 for any natural number n. Okay, to prove that 2n plus 2n plus 2 plus 2n plus 4 is divisible by 6. Now if you add all this, okay, you get 2n plus 2n plus 2 plus 2n plus 4. So there are 3 2n, yes. So 6n plus 6, if you take 6 common to bracket, you get n plus 1. Okay, so as sum is multiple of 6, it is divisible by 6, okay, for any value of n. Okay, fifth one, theorem: prove that infinitely many points lie on the line whose equation is y equal to 2x. Okay, now some hint is also given. Consider the points n and 2n for any integer n. Okay, we have to show that there are many points. Okay, to prove that there are infinite numbers of points on the given line. Okay, proof: consider the points n and 2n for any integer n. As n is integer, means n is a subset of z, and z is a infinite set. Okay, minus c dot 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 minus 3 minus 2 minus 1 0 1 2 3 dot dot dot, that means to infinity, which are infinite. Hence line should have infinite numbers. Okay, because for every value of n you will have, that is for x you will have y. Okay, so that shows that this line will have infinite points. Okay, now this is a very interesting part of this topic. You will really enjoy this. Okay, read this. Sixth one: you must have had a friend who must have told you to think of a number and do various things to it, to that number. Okay, it means to that number. Okay, add or subtract or multiply or something like that. Okay, and then without knowing your original number, telling you what number you ended up with. Okay, here are two examples. Examine why they work. Okay, let us see some examples. Okay, got it? Very, very interesting. So first one, interesting. Choose a number. We will read all these operations first, and then we will tackle one by one. Okay, don't get confused by all these operations. Okay, so choose a number, double it, add 9, add your original number, divide by 3, add 4, subtract your original number. Your result is 7. Okay, answer, we'll take one by one. choose a number. Choose a number. Let us take an 8 and in general x. Now next is double it. So 8 into 2 is 16. Here 2x. Add 9. Add 9. So 16 plus 9 is 25. Your 2x plus 9. Add your original number. Add your original number. So 25 plus 8 is 33. And here 2x plus 9 plus x is 3x plus 9. Okay. We were here. Now divide by 3. So 33 divided by 3 is 11. And here also 3x plus 9 divided by 3. You take 3 common. So you are left with x plus 3. Okay. Now with 3 cancels and x plus 3 you are left with this. Okay. Now here also your original number plus 3. Okay. Then add 4. So to this you are adding 4. 11 plus 4 is 15. Even here x plus 3 plus 4 is x plus 7. Okay. Next is subtract your original number. Now you are subtracting your original number. 15 minus 8 is 7. You are left with 7. And here x plus 7 was your this answer. You are subtracting original number minus x. So you are left with again 7 after cancelling this x and x. Okay. So last one is your result is 7. So your result is 7. Correct. Yes. Here also 7. Here also 7. Okay. Now these are some basics operations. Okay. You know what you have done. Okay. Simple operations. Okay. Just we have some explanation here. You initially double your number here. Okay. And then adding the same number. Here you are adding. You are doubling it and you are adding the same number. That means you are taking this number 3 times. Okay. In between, just to get confused, you are adding 9. Okay. See here. That means you are taking number thrice. This number thrice and adding 9. Adding 9. Okay. After dividing by 3 in this stage. Okay. You are left with original number. You are taking number taking it 3 times and again divided by 3. So you are left with the same number. Okay. And 3 from this 9 which you are again divided by 3 and you are left with 3. So after dividing by 3 you are left with original number and 3 which you get by dividing 9 by 3. Okay, very simple explanation. Okay. Now at this stage you are adding 4. See, add 4. That means you are adding, you are getting 3 from this 9 and adding 4. Okay, that means 7. Okay, so you add 4 and subtract original number. Okay, so you are getting original number, you are getting 3, you are adding 4. So this 3 plus 4 is 7. And at this stage, you are subtracting your original number, whatever it may be. You are left with 7. Okay, 7, you got it. You got 3 from here, 9 upon 3, and you are adding 4. So that 3 plus 4 gives you 7, which is the answer. Okay. So after many operations for any number, you are going to get answer 7. Okay. And now the second example, write down any 3-digit number. Here we are taking example as 425. Okay. Make a 6-digit number by repeating these digits in the same order. Okay. So 425 and 425. Your number is divisible by 7, 11 and 13. Okay. So we will see this comment here. We will see the rule by which the divisibility of 7, 11 and 13 is decided, and we can see that any such three-digit number repeating even number of times, that is 2 times or 4 times, okay, are divisible by 7, 11 and 13. Okay, divisibility of any number by 7, 11 and 13 has a unique rule. Let us see this rule. Consider any number, preferably a 6-digit number. Let us take actual number. We have selected the number 236593. Okay, so after getting this number, we will see the rule. First one, make a group of 3 digits from right to left as shown. So write a number here and make a group of 3 digits. First write 3. So 593 here, 593 is one group, and 236 is another group. Okay, so after forming these groups, the second step is now subtract one group from other, smaller from bigger. Okay, so 593 minus 236 is 357. So that is the second step. Okay, and third step is, if the remainder or the answer this is divisible by 7, 11 and 13, then the original number is divisible by 7, 11 and 13. Okay, in the above case, this case 357 is divisible by 7, but not by 11 and 13. Okay, hence the original number 236593 is the original number, is divisible by 7 and not by 11 and 13. Okay, so on the similar basis we will check another number. Another number is 486948. Okay, so groups 948 and 486. So we have 948 minus 486 is 462. Okay, so 462 is divisible by 7 and 11 but not by 13. Hence original number 486 948 486 948 is also divisible by 7 and 11 and not by 13. Okay, so that is a rule. Okay, so we continue our discussion from last slide on this divisibility of any number by 7, 11 and 13 has unique rule. Okay, let us see this rule. Okay, now consider any number. We have seen two examples. Now this is the third one. Okay, consider any number as 348 348. Okay, now as we have seen the first rule, make a group of 3 digits from right to left as shown. Now this is 348 and 348. We have seen this. We have seen the 3 digits which you are repeating. Okay, second one, now subtract one group from the other. Okay, smaller from bigger. Now here 348 and 348, you get answer 0. Both the groups are same. Okay, and third one, if the remainder or answer is divisible by 7, 11 and 13, then the original number is divisible by 7, 11 and 13. This is the rule. Okay, in the above case or this case, okay, 0 is divisible by 7, 11 and 13. Hence 348 348 original number, okay, here 348 348 is divisible by 7, 11 and 13. Okay, now here is a comment. There are other rules by which we can decide whether any number is divisible by 7, 11 and 13. I have a video on this topic. One may refer that for further study so that it will benefit you in the competitive exam. This Video may not be the part, this I'm talking about this video. Okay, this may not be the part of the present syllabus, but if you study this, this will help you in competitive exams. Okay, so if you want a link, please write to me in the comment section and I shall always send you link. Okay, so you move ahead. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of problems on mathematical proof, Appendix 1, let me know through comment section and I shall solve it. Now please like, share and subscribe. Thanking you. Good luck.